So this next section doesn't appear in the textbook, but you see lots of these questions on the diploma, and they occur in our unit exams as well. So solving word problems, they do have a few actually in the review section and just a couple in some practice problems. So these are mostly to do with growth or decay, and there's two different equations we generally use. They're actually very, very similar, and on the formula sheet, you're going to have this y equals a times b to the power of t over p. So let's look at this second equation first. So we have where a is the final amount, AO is the initial amount, r is the rate of growth or decay, and t is the total time, and p is the time for one period. So here we have a, here we have a subscript 0, and that's just the amount we're starting with of something, whether that's bacteria or population or whatever it happens to be. Our b value, or our base of our power, is r in this case. And so that's the rate it's growing or decaying. So if it's doubling, this should be 2. If it's tripling, it's 3. If it's halving, it should be 1/2. So that would mean it's decaying. T then is the total amount of time. So it might, if it's over a day, it's over 24 hours, depending on our units of our P, which is the time for one thing to happen. So for instance, if bacteria doubles every 3 hours, P would be 3. And if you left it for 10 hours, then it would be 10 over 3. So, and all the questions kind of work the same way. The above one is pretty similar, except for this time it's to do with money or interest generally. We see an I there. It really doesn't matter though too much between these. They're actually very, very similar, and often this one actually might be the better equation there as well. So we still have a subscript O. That's still our initial amount. A is still our final amount. Now we have this 1 plus the interest rate. And why we have that plus 1 there? Let's say it's 3%. So we got to turn that into a decimal first. We'll divide by 100, so we got 0.03. If I go and multiply some number by 0.03, I'm going to calculate how much interest was earned. But what I really want is how much money I have now in total. So to fix that, it's actually going to be 500 times 1.03. The 1 comes from, this is our initial amount, is represented by that 1. The 0.03 is that interest rate. And once you know that, you don't really need this formula anymore. And sometimes this formula will actually mess you up because we have n, which is the number of times this occurs. The problem is sometimes we're compounding it semi-annually or quarterly or monthly. If you're not sure what that is, we're going to go over some questions pretty quick here. Our first example has to do with some fish. So they're in a lake. The population is increasing by 5% each year. So we want to write an equation to represent the number of fish present after t years. So use n subscript 0 to represent the initial population and n of t to represent the final population. All right, let's go back to that equation that we were actually given in the formula sheet. So y equals a times b and then t over p. So our y is our total new amount. So that's going to be n of t. A is our initial amount, so n subscript 0. And now b is the amount or the rate of change. Now it says it's 5% right now. But 5%, we divide that by 100, we get 0.05. If I plunk that into this equation, I'm going to find out how much it's increasing by that year. The problem is I want the total new population, so it needs to be 1.05. Again, this 1 represents the original population that we have. So we have times 1.05. Now, t we don't know, that's what we're looking for, so we still have t. Now, it's this period part that's a little bit trickier. It actually says in the initial equation each year. So that means that p is equal to 1, which means t divided by 1 is just t. So I don't actually need any of that. All right, there we go. So B, if there were 2,500 fish present in June 2012, how many would you expect to be present in 2017? Well, we've already got a nice equation for us. So this time we're doing 5 years from 2012 to 2017. So it'll be n of 5 equals to, well, our initial fish is 2,500 times 1.05, so that's our rate, and this time our t is 5. You can put that into your calculator all at once. you get 3,190.7. Now with rounding, you can't have part of a fish, so I'm going to round this down. Now I'd be very careful when I'm doing that. I'd look at how the question's asking. If it's just saying round to the nearest whole, then yeah, maybe this should be 91. This one kind of left it in the dark, so I'm going to put an or here and just make it very clear that, hey, this is if we're actually talking how many fish we have, but if you want me to round to the nearest tenth, this would be my answer. Right, for C, how many years to the nearest tenth would it take for the fish population to increase to double the number in June 2012? So this time I'm going to take 2, and we're going to go n subscript 0 and n subscript 0. So 1.5 to the power of t. Now we're going to do what we told you not to do before, which is I'm actually going to divide each side by n subscript 0. And we told you never to divide both sides by a variable. The thing that's special about this variable, though, is it doesn't change. So whatever this, I could put a number here. I could put 5,000. I could put 5,000 here, and they're going to both be the same. We're going to divide by 5,000. We're not losing any answers here, so that we're okay to do that. So then I'm going to go 2 times 1.05 to the power of t. And here we've got a problem. We've got no way to solve this right now. Logarithms is how you would normally do it. We're going to do it using graphically. We've shown this before, so I'll just give you the answer. It's t equals 14.2 years. All right, our next example. We have a laptop computer we purchased for $2,500. The value of the computer depreciates 30% per year. Now, if you're not sure, depreciate just means we're losing value. So if we're talking trucks and cars and any, really, houses will appreciate a little bit, but sometimes that's more just to do with inflation, and the value goes down over time unless you're doing some upkeep or something on things to make them hold their value. So if V is the value of the computer after t years, then what exponential equation could be used to represent this situation? Okay, so let's look back at that formula sheet. A times B and to the power of t over p. Now in this case, where our y is our new value, so that's V in this case. A is going to be our initial amount, so that's 2,500. Now our rate of change, it's saying 30%, which means that our new value is actually 100% minus that 30%. So we actually have a new value of 70%. We divide that by 100, we get 0.7. So that means my rate of change is going to be 0.7 here. Now the time period in this case, we don't know, so it's still going to be t. And then for the p-value, it says per year. So t is per year as well, so this is over 1. Again, t divided by 1 is 1, so we don't need that divided by 1 there. All right, B. After how many years will the laptop be worth less than $250? Answer to the nearest tenth of a year. So our value rate here is V. So we're going to go $250 is that V variable times 2,500 times 0.7 to the power of t. Divide both sides by 2,500 and you get 0.1 equals 0.7 t. Now you would need a logarithm to solve this. Again, you're going to have to use a graphing calculator for now. And so that tells me that t is equal to 6.5. But that actually doesn't answer the question because it says the laptop will be worth less than $250. So at exactly 6.5 years, it'll be $250. Well, we want any time period that's greater than 6.5 years, we'll make it so the computer's worth less than $250, which is a little bit sad to think that in 6.5 years, you're losing $2,250 just like that.